Alright, this video will take you through the answers to test 5. Let's start with the multiple choice, 1.1. We're given a circuit and asked to identify component X. So let's go through some of the reasoning. We're told that the current is 1 ampere, so that's the total current flowing through the circuit. And the resistor, the unknown resistor, has a voltage of 1 volt over it. And there we go. No internal resistance, and so the 3 volts over the battery is also the voltage of the external circuit. And the question is, what is component X? Alright, so the battery is delivering a total of 3 volts. Let's look at the 2 ohm resistor. If we use Ohm's law to calculate the voltage over that 2 ohm resistor, V is IR, I we know is 1 ampere, R is 2, so 2 volts is used over the 2 ohm resistor. The other resistor has a voltage of 1 volt, and so our total external voltage over those 2 resistors is 2 volts from the 2 ohm resistor, 1 volt from the other, which gives us a total of 3 volts. Now the battery is giving off 3 volts, and those 2 resistors are using 3 volts, and so the voltage over X has to be 0. And so that means that it can't be a resistor, because otherwise there would be a positive voltage. It can't be a lamp either, because that would also have a voltage. It can't be a cell, because otherwise the total voltage would increase above 3 volts, which means it must be an ammeter. So the answer to 1.1 is C. Right, 1.2 is one of those ratio and proportion type questions. We're using the force between 2 charges, so we're using Coulomb's law. And F is K, Q1, Q2 over R squared is that expression. Now with the changes, we're then considering the new force, so we'll indicate that F new. K is the constant. We're told that Q1 doubles, and so the new force, the charge is 2 times Q1. Q2 remains the same. And we're told that the distance halves, so our R is now half R, and we square that. We pull the numbers out. On the top we pull the 2 to the front. On the bottom we square a half R and we get a quarter R squared. 2 divided by a quarter gives us 8, and then we've got the K, Q1, Q2 over R squared, which of course is our original force. And so F new then is 8 times the old F, and that means that D is the correct answer. Alright, 1.3. Diagram of a motor, and we're trying to indicate which direction it spins. Let's look at the battery. The long side is positive, short side is negative. So the current flows from positive round to negative, and so in the wire AB we can see the currents flowing from A through to B. The magnetic field goes from north across to south. And so if we use Fleming's left-hand motor rule, apply it to AB, forefinger from north to south, current from A to B, that indicates, you can see that little yellow arrow, that AB will experience a downwards force. If we apply the motor rule to CD, we'll see that CD experiences an upward force, and so the spindle will spin in an anti-clockwise direction. So that means A and C we can cross off. So B gives us anti-clockwise, and D gives anti-clockwise until it reaches vertical position and then reverses its direction. Now you'll notice in the diagram that there's a split ring commutator, and the purpose of that is to switch current every half turn to prevent this exact problem. So B is the correct answer. It won't reverse direction because it's got a split ring commutator. So 1.3 correct answer is B.